Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at classifying triangles. So if you're not aware, a triangle is a side with three straight edges. Note, we don't count curved lengths as sides. So we need to be able to classify triangles according to their side name and their angle name. So let's look at the sides of a triangle. There really are three options. Either the triangle can have no equal sides, in which case we call it scalene. The triangle can have two equal sides, in which case we call it isosceles. Or the triangle can have all its sides equal, in which case we call it equilateral. Now just note that if you have different numbers of dashes, that indicates sides are not equal. So side with one dash is different to the side with two dashes, is different to the side with three dashes. But here I've used the same number of dashes that indicates these two sides are equal, and similarly for here. So it turns out that in any triangle, the number of equal sides is the same as the number of equal angles. What does that mean? Well, this scalene triangle has no equal sides. It turns out that if a triangle has no equal sides, it also has no equal angles. So I'm going to mark each of these angles with a different symbol to indicate they're not equal. None of these angles will be equal. So for an isosceles triangle, it has two equal sides. It also has two equal angles. The angles that are equal are what we call the base angles. These two angles are equal where these equal sides meet the non-equal side. And then this third angle here is different. That's why I'm marking it with a different symbol. So for equilateral triangles, they have three equal sides, so all of their angles are equal. Now, because the angle sum of any triangle is 180. If the three angles are equal, then each of those angles is equal to 60 degrees. So an equilateral triangle has each of its internal angles, its interior angles, equal to 60 degrees. So that's how we classify triangles by side. We just look at how many equal sides there are, and the number of equal sides is the same as the number of equal angles. So how do we classify triangle by angle properties? Well, note, the smallest two angles in any triangle are always acute. When we classify triangles by their angle property, we're actually looking at the largest angle in the triangle. So it turns out that in any triangle, regardless of whether it's scalene, isosceles, or equilateral, the largest angle is always opposite the longest side. So in this triangle here, it turns out this is the longest side. So this will be the largest angle, and you can see clearly that this largest angle is acute. That means it's below 90 degrees. So in this triangle here, this is the longest side. It's opposite or facing the largest angle. Here, the largest angle is a right angle, so we call the triangle right-angled. In this triangle here, this is the longest side. So this is the largest angle, and it turns out here that this is an obtuse angle. It's more than 90 but less than 180. Now note that for any triangle, it can't have more than one right angle or more than one obtuse angle, because then the angles in the triangle would add to more than 180, which we know can never happen. So again, by the angle properties, we're just looking at the largest angle. So there are always two acute angles in every single triangle. If the largest angle is obtuse, we call it obtuse angle. If the largest angle is right, we call it right angle, and if the largest angle is still acute, we call it acute angled. So we need to know combinations of these. So we can have a scalene triangle that's any of these. We can have an acute angled scalene, or a right angled scalene, or obtuse angled scalene. Similarly for isosceles triangles, they can be acute angled, right angled, or obtuse angled. Equilaterals are a bit different. Because their angles are always equal to 60 degrees, equilateral triangles are always acute angled. You can't have a right angled or an obtuse angled equilateral. All right, let's have a go at classifying some triangles ourselves. So we're going to classify each of these triangles using the side and angle name. So firstly, this triangle here, it's got two equal sides, so we know it's definitely isosceles. Now, it looks to be an acute angled triangle, but let's double check that. We know that this angle's 55, so this angle here must be 55, for what I said before about equal angles in an isosceles triangle. So that means here the largest angle here must be 70, because 55 plus 55 is 110, and you need 70 more to get to 180. Remember, the angle sum of any triangle is always 180 degrees. So here the largest angle is acute. It has two equal sides, two equal angles, so it must be an acute angled isosceles. And I'm happy for you just to write acute isosceles. All right, let's look at this triangle here. So we have a triangle with two angles equal to 60 degrees. So you might think, oh, cool, two equal angles must be isosceles. But remember, the angles in any triangle add to 180. So this third angle must also be 60, because 60 plus 60 is 120. You need 60 more to get to 180. So this triangle actually has three equal angles. That means it must have three equal sides and will be equilateral. Remember, equilateral triangles are always acute. You don't really need to write acute equilateral. All right, let's look at this triangle here. So we've got a right angle and a 45-degree angle. Now we can't just look at it and say, oh yeah, it looks scalene. We have to have some reasoning to back it up. So if we have a 90-degree and a 45-degree angle, the third angle is 180 minus 90 minus 45. It's also 45. So because this triangle has two equal angles, it must be isosceles. Because the largest angle is a right angle, it's a right-angled isosceles. And just so we know, it must be these two sides that are equal based on where the angles are. So we can call it a right-angled isosceles, or simply write right isosceles. So we've given it an angle and a side. All right, what about this question here? A triangle with one angle 30 degrees and the other 40 degrees. So what would be the size of the third angle? We need to know that before we can classify it. So the third angle is going to be 180 minus 30 minus 40, which gives 110 degrees. So what type of triangle will this be? Well, we've just found that the largest angle is obtuse. It's more than 90 and less than 180. So this will be an obtuse triangle. What we also know is that there are three different angles. Since there are no equal angles, there will be no equal sides, and we refer to such a triangle as scalene. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.